Welcome to section 13.2. We're dealing with angles and what we call radians. And we're going to talk about basically how do we get from degrees to radians, how do we use some formulas, things like that. So let's start from the beginning with going back to geometry and talking about how to put an angle on a coordinate plane. Okay, so the angle can be formed by using a ray. Now a ray is a directed line segment. So as you look, this is the idea of a ray. It has a starting point and it goes towards a position, okay? An angle formed by fixing one ray called the initial side and rotating it called the terminal side about the origin. Okay, now let's talk about what in the world that means. Okay, here's what it says. If I start, your initial side, okay, is always going to be at the positive x-axis. So when you go through and start, your initial side when you draw angles is always at the positive x-axis. Then you take it, and in order to find the angle, you take the angle, and wherever you end is where you put your terminal side. So this is my angle, which we call theta. Now we're going to talk, we talked about angles yesterday in our unit circle video, and so I just want to talk again, and we'll relay some of that again. But the idea is, again, you start at your positive x-axis and you work counterclockwise around. Okay, so keep that in mind. As you're doing angles, again, you're moving counterclockwise. An angle in standard position, if its vertex is at 0, 0. And what that means is if this point, the end of your ray is at 0, 0, and the initial line, again, we said it stays on the positive x-axis. So this initial side is the positive x-axis with its starting point at 0, 0. Okay, so we're going to draw this. What I'm going to do is I start here, and here's my initial side. Now my goal is to go 405. What we know already is that one whole revolution around is 360 degrees. And so the question is, how much farther did you have to go to get 405? So what I'm going to do is 405 minus 360, because I'm going at least one revolution around, you get 45 degrees. Well, since this is 90 up here, 45 is going to be halfway between. So the halfway between is going to be my terminal side. And as I continue this around, I'm going to draw my arrow for where it ends. That shows me which position or which direction I'm going in. So I start on my positive x-axis, and I work all the way around until I get to 405 degrees, and I put an arrow at the end. Again, you need that arrow in order to show which direction you're going. And the reason is I look at question B, where again I start at my positive x-axis. If I'm going back 65 degrees, again, this would be back 90, so 65, and again, we're just kind of approximating, is like right here. Now, again, I need the arrow to say which direction I'm going. And so as you're looking at it, this tells me, hey, I'm going back 65 degrees. When I go counterclockwise, it says I'm going 405 degrees, and you should, again, label it. And so that's kind of what you're looking for, is where you start, where you end, and in which direction you're going. Now, you don't need protractors, but if you tell me it's negative 65 degrees and you give me an angle up here in quadrant 2, I am going to mark it wrong. So it's an approximation as we go through, okay? Now, let's take a look at degrees and radians. And we talked a little bit about this in yesterday's unit circle video, but if we want to go, degrees and radians basically are the same thing. They're just represented differently, and the higher you go in mathematics, the more we work with radians, which means in terms of pi. So in order to get from a degree to a radian, you multiply by pi over 180. In order to go backwards, you multiply by 180 over pi. And I'm going to show you kind of how do you tell which way to go. So let's start. 315 degrees. If I want to go to a radian, it means I need a pi in it. Since degrees is already there, and I'm going to put it kind of over 1, to get rid of a degree, I need to put 180 degrees on the bottom so that my degrees will cancel out. therefore a pi goes on top. So I take this as 315 over 180 with a pi, and I would use your calculator to reduce this. You cannot put pi in your calculator and hit math fraction, it won't work. So if I put the pi kind of at the end, I take 315 over 180, math fraction, and what I end up getting is 7 pi over 4, and I just put the pi back in it. Okay? So the second one, let's go backwards. If I look at pi over 6 radian, the pi is on top. I don't want pi anymore because I want to go to degrees. So to get rid of a pi, I put it on bottom, and 180 degrees goes on top. The pi's cancel out. I'm left with 180 degrees over 6, which is 30 degrees. Okay, so let's try one more. This can help you get around your unit circle also, converting, but again, like I showed you yesterday, I want you to only know 2 radians and then count around. So take a look, 200, because it's a degree and I want to get rid of it, I multiply with my degrees on the bottom and my pi on the top. Degrees cancel out, so I get 200 pi over 180. Again, don't put the pi in there when you're using your calculator, just 200 over 180 reduces to 10 pi over 9. Last one, let's convert this back to degrees. Since I have a pi, I put pi on the bottom and 180 degrees on top. Pi cancels, you're left with 180 degrees over 5. When you divide 180 by 5, you get 36 degrees. Okay, so the overall idea of converting is not that big of a deal. Again, at this point in time, if you look at it and go, oh, I get it, go back to your unit circle and make sure you understand how each degree on your unit circle got to be a radian, or see if you can count your way around. Let's try some formulas. There are 2 formulas, arc length and area of a sector. We expect that you know both of these. The arc length is basically what is the distance as you go around the circle. The area is like what area does a pi piece make up. And that's, I think, how they discussed it kind of in geo, is how big is the pizza slice or how big is the slice of pie. Okay? Here's the number one thing. Your angle has to be in radians. It has to have a pi in it. So this angle, again, has to be in radians. If you use a degree, you will get it wrong. Okay, so just kind of be aware of that. Okay, sorry for that break. Taking a look, we want to talk about this in terms of radians. Okay, so as we do this, we're going to ask you for the arc length and the area of a sector. Here's our radius. But they give you your angle. Here's the problem. We don't want 60 degrees. So we're going to take our 60 degrees and we're going to convert it to a radian by multiplying by pi over 180. So you get 60 pi over 180. 60 over 180 reduces to pi over 3. Okay, so we take pi over 3 and we stick it in our arc length formula. So arc length, we know, is the radius times our angle. So my radius is 15. My angle now is pi over 3. So if I multiply these, you end up getting 5 pi. But truthfully, we don't know what 5 pi means in terms of a distance, so I'm actually going to take a decimal here. And the arc length is approximately 15.71. Now you need a label. Because our radius is in inches, we're going to say the distance around the circle, or the arc length, is also in inches. When I do the area, I'm going to do the same type of thing. 1/2 times my radius squared times my angle. So my radius is 15, so 15 squared times my angle of pi over 3. Okay, now you could multiply this out. I would multiply the numbers personally. When you do that, you get 112 nope, sorry, wrong number I'm looking at. Let's try again. You get 37.5 pi, but again, I don't know what that means, so I'm going to multiply this out, and the area is 117.81, and because it's area, we say inches squared. Okay, so again, as we're looking at it, this is the idea. What I want you to do, though, is look at the bottom. There is one more question, and you'll notice it starts off with on your own. You want the notes points, we're going to finish this. What you also want to make sure that you do is watch the next video on the unit circle. You want to make sure that when you come to class tomorrow, you can fill in the unit circle completely. So degrees, you want to fill in radians, and we talked about exact trig values yesterday, so trig values as well. So tonight, here's what you need to do. First thing, complete this. Second thing, finish up the unit circle, okay? We want to make sure we know all of it, because when we take the quiz for 13.1 to 13.3, part of your quiz will be a unit circle quiz as well. Okay, thanks for watching 13.2.